Hi, I'm Javier, and I want to speak today about how you can ingest and analyze market data in real time using only open source tools. And you might be wondering, what's so special about real-time market data? Why cannot I just use the same data lake, the same tools I already have for big data analytics on my organization? Well, and the thing is that real-time data, market data, it's special. It has something in common with general analytics that you have on your data lake, in that the data can get very big. For example, last week I was working with some Standard & Poor's futures, and for one day of data, I was seeing about 750 to 800 million records, which is large enough. And the thing with this data is that it never stops. Even during off-market hours, data is always coming. So you cannot really say, I'm going to wait until I have all the data, and then I stop everything, and I start a batch process in which I run my analytics and I produce something, as you will do with batch analytics. In this case, you need to have the pipeline always available for ingesting and querying. And ingestion can be bursty. Typically, in many moments, in very low moments, you are going to be seeing maybe only about 10, 15,000 records per second, which is quite easy to manage. But at peaks, you might be seeing 250, 300,000 events per second for a single index. And that's tricky to handle. If you are monitoring multiple indexes and multiple instruments, you might be easily getting into millions of events per second. And you need to make sure that every time you have new data, you persist the data to persistent storage, and you make the data available as soon as possible for querying, because your users, unlike data lake users that typically don't care about a few seconds, even a few minutes or hours latency, when you are speaking about real-time market data, your quants, your machine learning models, your data analysts, they really want to have fresh data. They want their data to be available for querying as soon as possible. When you are ingesting potentially millions of records per second, it can be very tricky to persist the data, make it available, show it in the queries, especially with data that might be coming out of order, might be lagging behind. Well, streaming data is very specific, and even if there are some tools you can use, the streaming data can be stored on your data lake also, and you can use the tools you already have for doing historical analytics. But the real-time aspect of the data, you need to have specialized tools for that. The good news are that there are many tools you can use for working with streaming analytics. If you were asking me 12 years ago, I will tell you, you are out of luck. There is this guy, Matt. He's a VC analyst, and he is specialized on data. He's been publishing this big data landscape for the past 13 years. Actually, now it's called the Big Data, Machine Learning, and AI Landscape. And this was the first year he was publishing the report. As you can see, 12 years ago, if you wanted to do big data analytics, plenty of options, both in open source and in proprietary tools. But if you wanted to do real time, in open source, there was only one option installed. I used it and I can tell you it was not great. I mean, at the moment it was awesome, but it was not real time as we know it today. And you have a couple of options for real time in proprietary, not really for generic data analytics. So it was kind of tricky if you wanted to do real time at the time. The landscape has changed dramatically in the past few years. Now, if you look at the latest report, which is the last from last year, the 2025 hasn't still been published, but if you take a look at this, it has changed quite a bit, yeah? Now it includes also machine learning, but you can see here in the open source category, it's like a lot of different options to choose now. And if you zoom into any of these subcategories, you can see plenty of tools for many different things. Real-time databases, you can go with ClickHouse or with Redis or with QuestDB, which is, by the way, the database where I work. Or you could go with some streaming in-memory database for some market analytics as well. Some of these new SQL or NoSQL databases will also be available for some types of market data in real time. When it comes to streaming data, message brokers or stream processors like Kafka or Flink or Apache Spark. Again, plenty of options. Even for things like data formats. Should I use JSON, Parquet, Arrow, Avro, Iceberg, which is now very much in fashion? As you can see, plenty of options for any part of the stack. So in theory, if you want to build a streaming pipeline for analyzing, ingesting, analyzing data in real time, which is what this talk is about, it should be as easy as just choosing the different components. How hard can this be? Just pick one tool for data ingestion, just pick one tool for data analytics, just pick one tool for real-time dashboard, and another tool for data science and machine learning. And you are good to go, right? Am I right? Well, if you want to go to production, probably you want to have monitoring, but that's about it. You choose your monitoring agent, the database where you're going to be storing the monitoring, the dashboard, and the alerts. It might be a single product, but sometimes they are separate. And with that, you are ready to go. Only that in real life, these components very often are not single components, but they are different things. You have the data source, the message broker, and then the listener who is then storing to the database. And the database might be writing to different types of forecasting. One might be for machine learning models, the other for data science. So there are many different pieces, and you need to choose different components. You need to configure them together, and suddenly it feels like it's like everything all together, all at once. It's like too many things, like, too many moving parts. It's very hard to sometimes configure some things with another. There is not enough information about how to integrate multiple components. So after a few years of building again and again and again projects about working with streaming data, I've been working with big data mostly for the past 12, 13 years, and a big chunk of that has been on streaming. I started with e-commerce analytics, and then I moved to finance. So after dealing with having to set up analytical pipelines once and again, I decided I will create a template in which I choose some components, I pre-configure the components, and I put everything together. So you can just go to GitHub, you can just download this template, which is Apache 2.0, you do Docker Compose up, and then you start everything you need to do data analytics, including some demo data sets. So when you start my project, my GitHub project, you are going to get some ingestion scripts, sample scripts to ingesting trading data, transactions data, then some data which is not finance oriented, like data from GitHub or IoT, but you get like trading events and transactions for financial data. I give you scripts in different languages to ingest the data, some of them browser-based, like Jupyter Notebooks, and some of them script-based, but shell-based. But yeah, I have examples to ingest data from different data sets. We ingest the data into a message broker. In my case, I'm choosing Kafka. I will tell you later why. From Kafka, we ingest the data into a database. In my case, I'm choosing QuestDB. I will also tell you in a few moments why I went with QuestDB. We can send the data directly into the database, or we can send the data to Kafka and Kafka connect into the database. And then the template also has a Telegraph agent for capturing metrics and doing monitoring. It starts a Grafana dashboard for real-time dashboards and alerts. And it starts Jupyter Notebooks with some scripts and demo scripts for data science and forecasting of time series data. So you get this out of the box. Everything is pre-configured, everything works together, and you have examples in which you can ingest data on one end, store everywhere, and then see real-time dashboards on the other end. If you don't like any of the components, you could just replace the component, plug in a different thing, and just reconfigure that part, and everything else should work. So this template is available for you to use if you want to do real-time analytics with open source tools. And the rest of the talk is going to be about presenting the different components, I have in this repository, why I chose them, and quick demos of the different parts. So the first part is data ingestion. Sometimes when you are speaking about finance, you really want low latency and you want to ingest directly onto a database. This repository also supports that use case. You will find templates that ingest the finance data directly into QuestDB, directly into the analytical database, skipping completely the broker. But very often, you will see when you are working with streaming analytics, you want to use a broker in between so you can decouple ingestion from your database. Imagine, for example, you want to restart the database for any reason. You want to restart the machine because you are adding CPUs, or you want to upgrade to a new version. If you have something between your database and your source of data, then you can keep sending data to the message broker, and then you can stop the database. At any other point in time, you can restart, and the database can catch up with the broker. So having something that it stays in between, it helps you decouple, but also it helps you if you are going to be reusing the data into multiple systems. Maybe the data you are sending to the database, you are also sending to other places. So Kafka can be that tool in which the data first lands before sending to the rest of the system downstream. Apache Kafka is a very popular tool, a very popular message broker. It scales as much as you want. You can add multiple brokers. Brokers are like instances. So you can add multiple brokers and then you can scale horizontally. It's not as easy as it sounds, but yeah, it's fairly simple to scale a Kafka cluster compared with the alternatives. The data you can configure for data to be replicated, so you can have multiple brokers, and you can configure your system to replicate the data always in different brokers for high availability. And the way you work with Kafka, you define topics. A topic will be similar to a table. So you define a topic and you can start sending data. And you can send any data you want there. You can send data in text format. You can send data in JSON. You can send data in a binary format. You can send data anywhere you want. Apache Kafka is agnostic. But if your format, the format of the data you are sending, if it supports schemas, like for example, in JSON or Abro or protobuf, you can use the Apache Kafka schema component, the schema registry, so you can enforce schemas in your data, which is quite cool for production use cases. So basically, Apache Kafka is a very powerful tool. You can send data in any data format. And for the data format, I'm using Abro. You might be familiar with formats like JSON or like Parquet or other formats. So Abro is a popular format. It's very similar to JSON, in which you can have data which is nested inside other objects if you want. But unlike JSON, it has a rights type ecosystem. So in Abro, you can specify that this particular field is a string, and this one is a float, and this one is a timestamp, and this one is an integer. And it supports a schema evolution. If you have one consumer reading from a message and is using an older version of the client, and the message already evolved, with Abro you can actually map between older and new schemas. So it's also very nice for production. Unlike JSON, it's a binary format. So it's very efficient down the wire. So many people, when working with Kafka in intensive use cases, choose formats like protobuf or like Abro. In my case, I went with Abro. No one specific reason at all against protobuf. I just like it. It is simple enough to use, and you can just use directly with Kafka. I'm going to stop here for the first demo today. So I started my template in this console with Docker Compose app, and I have all the components running. So now I can go to my browser and import 8888. I have this interface, this web interface. I will tell you later what this is, but this is basically Jupyter Notebooks, which means I can execute Python code in the browser. And as you can see, I can also have like rich text, like for having comments or headers or whatever, combined with the code. So I can execute just code. In this case, I'm going to be streaming some data into Kafka. What I'm doing here, I have this script in which I'm reading some data I have on a CSV. On this CSV, I have data from an hour of real trades, finance trades from cryptocurrency. And what I'm doing in the script, I read the whole file in memory and I replay the data again and again. So I'm just going to resend all the data as if it was real time into Kafka. As you can see here, I am first defining my Abro schema. So these are the columns I'm going to send. And then here, in this case, I'm doing with Python. You could do it with Java, with any other language. Now here, I'm sending the message with that format into Kafka. So that's it. If I go down to the web console, I can use Kafka reader just to read the data and sending in Abro format. And here you are. You can see data is flowing right now into this topic. So that's how it works. The data is automatically sent to the trace topic with my script. Next step, now that the data is flowing into Kafka and I have verified I can read the data from Kafka, I'm going to see how to get the data from Kafka into my database. Kafka is not doing push. So every time you have data into a topic, Kafka doesn't send the data to any consumers. If you have a consumer that want to consume data, a client from Kafka, you need to actively pull data from Kafka. You need to ask if there is new data on the topic. And Kafka keeps track of the offset, which was the oldest data and the most recent data, that a consumer already consumed. So when you ask Kafka, Kafka will know if you have pending data for you, but you need to ask to get the data. So rather than building yourself a client that is doing that, you can use Kafka Connect, which is a component standard in the Kafka ecosystem. Kafka Connect, it's a component that can run alongside your Kafka cluster. And basically, you can configure Kafka Connect with many different sources. In my case, I'm going to configure the source of data as this Kafka topic. And you can configure many different outputs. It has a lot of plugins you can choose from. So in my case, I'm going to be reading from a topic and I want to store data into my QuestDB database. Kafka Connect can apply simple transforms, like for example, flattening data which is nested, or renaming columns, changing data types. You can do that if you need it. And I'm going to show you here the configuration for my Kafka Connect. My connector that I can configure in JSON or in YAML. In my connector, I specify which is the source of my data. It's a Kafka topic. The Kafka topic is named trades. And every time there is new messages on trades, Kafka is going to send, in my case, to QuestDB because I'm using the QuestDB connector. And then I can configure some metadata where the data is going to be sent. In my case, these are on Docker, so to the local host. I'm configuring which are the data types, which is the column with the timestamp, and so on and so forth. And with this, I can go now to the QuestDB web interface, and I can show you that some data is actually flowing into the database. See here? Okay. So what is this QuestDB? Well, QuestDB, it's an open source database. It's Apache 2.0, so you can use this for everything. It was started about 10 years ago, and the project was started in the finance world. So the user base is mostly finance. We also have some people working with QuestDB on energy markets and aerospace, e-commerce, and also other sectors, but finance is a large chunk of the user base. So it is designed to ingest multi-million rows per second and to fast read, to fast query over multi-billion data sets. You query QuestDB with SQL. So, it's compatible with the Postgres wire protocol. So any library that speaks Postgres can connect to QuestDB. You can also use the REST API to query the data. But even if we are compatible with the Postgres protocol, we are not Postgres. So what we offer is our own SQL with some extensions. For example, for downsample data or for joining data by approximate time. Maybe you want to join the price table and the trades table and you want to find the most recent price, but it's not exact timing, so you can do as of join directly into QuestDB. We offer finance functions, for example, to do things like working with order book data and see the spread between the bids and the ask and so on and so forth, calculating mid prices, a lot of extensions for finance. But in the end, we are just a time series database. You ingest data using a protocol called ILP. You can ingest data directly with the REST API or using any of the client libraries we have in different languages. We have libraries in C++, .NET, Python, Rust, Java, of course, Go, and and JavaScript. So yeah, 7 different languages. The data is stored in columnar format. You can choose to store the historical data automatically on Parquet. So if you want to integrate with your data lake, your data can be automatically stored in Parquet in object storage, so you can just integrate without having to duplicate the data. Same thing, if you want to do machine learning on top of the Parquet files, you can just consume those files. And that's about it. That's QuestDB. So I chose it because it was created for market data, and it's a time series database. So it fits very well the concept of analytics over for market data. And as I said, it's the database where I work for. So, it makes sense for me to use QuestDB because I really know it quite well. Once the data is on QuestDB, I want to present the data somewhere. And the real-time dashboard open source that I prefer is Grafana. Grafana didn't start as it started also about 11 years ago. It didn't start as a business tool. It started more like a monitoring, infrastructure monitoring tool, but more and more people are using Grafana for business metrics because it's really built for real time. Other tools are built for batch analytics and then they adopted real time, but Grafana from the day one, it was developed as a real time dashboard, and you can really notice it's very easy to work with real time with Grafana. It has a lot of connectors, including of course connector for QuestDB, and if you want, you can just configure alerts on any metrics. Let me show you for a second how you can work with Grafana. So this dashboard is refreshing in real time every 250 milliseconds. And these charts you see here in Grafana, they are written just in SQL. So if I open any of these charts, for example, this one here, I can see it's just a query with a sample by. So we are aggregating data by time intervals. And you have the results of the query. And then you can choose, as in any other visual dashboarding tool, you can choose from multiple chart representations. You can change the legend, change the colors, but it's fairly simple to work with because you only have to configure the connection to the database and then just run your SQL. You have macros to filter by the time range that you have here in the dropdown. You can add variables to the dashboard. Pretty standard stuff, but very powerful, and I really like it. So Grafana is one of the components. The next part will be data science. Data science and machine learning means many different things for different people. So in this started template, I wanted to keep it easy. So I'm just using Jupyter Notebook. As you saw, Jupyter Notebook are these scripts I can run directly on the browser. So you can combine Python code with Markdown. So you can have nice text and also snippets of code. It's very easy to share with other developers. If you want, you can just point to the same URL or just save the template with the status and send it to another developer. And what I did here for data science, it's a small example, let me show you, in which I'm first installing Facebook Prophet, which is a Facebook library for time series. There are other libraries more powerful, but this one is very fast to train and good enough for beginners. So I'm just querying QuestDB here to downsample data at regular intervals because that's what Prophet expects. With that data, I'm training the model, And now the model is trained, I can run a prediction. And here you see the trend with the small data I have in this demo I've been ingesting. And we can do the same with other tools, like for example, in this case, with scikit-learn, which is another Python library for data science. Again, I'm running the query in QuestDB, connecting with the process protocol, getting the downsample data, training the model. Model is trained now. I can execute the prediction, and it's all good to go. Okay? So yeah, from here you could take it like to any other point, but I wanted to show you that it's fairly simple to integrate machine learning into your workflow just by querying data. Of course, you could also query directly the Parquet files, but in this case, we are doing it like this. For monitoring, I chose Telegraph. Telegraph is a monitoring agent that can collect metrics from many different places to have plenty of plugins. So in my case, I'm going to be collecting metrics. I'm going to show you here the configuration. I collect metrics from the Java virtual machine, from the Kafka broker, and also collecting metrics from QuestDB. And Telegraph can read metrics from many different systems, and then it can store the metrics in many other systems, for example, in Prometheus. And when I was doing this template, I was thinking of integrating Prometheus, but I thought it was too much, too many components already. So I thought, since QuestDB is already a time series database, even if it's not really designed for infrastructure monitoring, it can be used for that. I chose that as the output of the Telegraph metrics, I was going to store the data into QuestDB itself. So basically here in the configuration, I have QuestDB as the output of the metrics. So if I go to my QuestDB web interface, you can see here I have these tables. So now, if I query the data, you see some metrics here for QuestDB, and also some metrics about my Kafka brokers. Okay? So yeah, from here you could just run your queries or build a dashboard on Grafana for your monitoring, or just change the configuration and ship to Prometheus or to wherever you want to send the data. So this is what I wanted to present. I wanted to show you that if you are new to streaming analytics, or if you are missing some components, you can just download the template and you have end-to-end analytics, including demo scripts to produce random data with different shapes. And you have data from ingestion up to the dashboard, going through Kafka, Kafka Connect, QuestDB, and Grafana in between, including data science. There are many things I didn't cover. I didn't include in the dashboard any data quality or governance tool. The repository is not really production ready. It doesn't have high availability components. You start everything with Docker Compose app. But hopefully, it's a very good starting point so you can start using it in your projects and take it from there. Just add more configuration or replace any components that you don't need, or as the one you will need to integrate with the project. And of course, if you like it, I'm open to any contributions you may have to the repository. Thank you very much and have a good day.